So we're now on box number 30. We did box number 29, which was the Mk1 7E and the Midland 77805. So now we're on box 30, which we start with this, and the next one in this box is a Comptron 40. So this has come from the mystery benefactor Alan in North Lincolnshire again. These are booked in as repairs, even though they're actually our sets, but this is how it works. Another free radio for you. This was given to me, and I know that they adjusted anything that would adjust, and it was filthy inside and out, etc., etc. He thinks it's a candidate for our dishwasher, so we'll have a look at that. Now there's two versions of the BInatone Route 66, and one of them takes a lot more aligning than the other. That's the early version. So when we open this up, in fact, I'll tell you what, we'll do an alignment for. We'll check what the alignment is first. So BInatone Route 66. It's a unique chassis in these sets. It's not that brilliant, but it's reasonably competent. And they're made in Japan. So the two versions, the early version uses a PLL02A synthesizer chip, which is really aimed at the American market, and so by lots of jiggery pokery it does UK channels. Then the later version uses the Sanyo LC7137 synthesizer and is much easier to set up. I do have the service manual, and let's hope it's the later version. So on the back, 018538. Now, I don't remember whether you've got a different number on the back. Is it stroke A? I really don't know. So I'm going to take some of the screws out, but not all of them. There's no reason I should be taking half the screws out. I'm going to be spending most of today on the organ, so I'm doing this at 8 o'clock in the morning. It's come with a power lead, and again, once again, I thank Alan most profusely for being so kind as to send these. Come with a microphone. That's not the original one. That's more of the type used on the radiomobiles. So we'll connect this to our handy crocodile clips, which I love to short out regularly. He says it powers up, so we don't need to be that cautionary. We've got a beast of a base station Fidelity 3000 to do in about 3 sets time, which is for me, but again it goes in the same job sequence. So 13.8 volts, 1.6 amp maximum power set up. So he's done the meter lamp, but he's done it with an LED. But seeing as it's my set, we can let that go. It's the right kind of brightness, but it would be nicer if it was a warm white, because you know, there weren't white LEDs in 1981 when this was made, so it makes it kind of wrong for the era. So we've got our handy piece of paper we used yesterday, which was the hymns for the February service. Yes. Don't see many of these. Another dealer didn't even believe me that there were two versions till he got one come in. Right. Are we ready? Picture in picture. Make sure we're set on high power CB. Yep. Yes, it is on high power. So it's doing, oh my goodness, we're on the 3 watt scale, so it's doing 850 milliwatts. No wonder it hasn't had anybody talking to him. Frequency, so we'll have a look at that. 2779075. A little bit lower than I would like, but it wouldn't sound off frequency at that. Deviation. Wallow. Oh no. Fidelity 1000, that would sound alright, but on anything else it'd be a bit choppy. It's well over the 2.5 maximum. So let's have a look at receive. So I'm setting the signal generator. In fact, I'll put the frequency counter on so you can see what I'm setting the signal generator to. I'm setting it to exactly what it's transmitting on, so that we're not expecting the receiver to be spot on frequency. We know that it's set around there, and then it's fair. We'll go on to the cyanide meter, which I'll actually switch on. So turn the squelch down. That's 0.3 of a microvolt we can actually just hear. Let's plug the extension speaker in through the test instruments, and we're not going to get any readings. Actually, that's better than his letter leads us to believe, but that very low power on transmit certainly is. You know what? It's doing 0.85 of a microvolt. So, the biggest killer here is it's only doing 850 milliwatts. And if we switch it to low power, go back to the test instrument, it's doing 350 milliwatts. Which isn't far off the 400 milliwatts it's supposed to do. So I'm going to key up. We'll switch it from low power to high power, so you can see that I'm not misreading the test equipment. So right, we'll finish taking the screws out, and if this is the later version, I'll be able to do this before I start my other work, and if it's the early version, well, we'll have to take a bit of a back seat. Now we'd have to unsolder the speaker. So we're going to have to use the spectrum analyzer, because these are bound to have been fiddled with. These are the filter for the harmonics, and when you get a set which has been known to be twiddled with, they could well be miles out. So these aren't part of the tune-up. These are the filter which are done with the spectrum analyzer. Your tune-up ends here. So it's a dusty set, and you know what? It's got lots of crystals in this. It's the early version with the PLL02A, so beggars can't be choosers, but it's an awfully big setup procedure. So this is the one where you start at page 1 of the service manual and you work your way through it. Just chop that. I think Mr. Chippy's got a bit of OCD and he wouldn't like that. So I just think he's probably been in a farming environment, and it's more of I've got a Henry vacuum cleaner at my side. I don't know whether any of you have seen this. A battery operated one, runs on proprietary 24-volt battery. But of course it saves having a mains lead, so just get that on it. You know what? I think I'll go over to the organ workshop and we'll get a paintbrush. So whilst the printer prints off a copy of the service manual, we'll carry on with a paintbrush. And hopefully that's a visual improvement. Right, so I've printed off an instruction manual and I've printed off a service manual. And we'll turn the soldering iron off for now. So we've got the specification in here, which we haven't got in the service manual. I suspect it's the last page, it is. So they're supposed to do 4 watts. See what the receiver's supposed to be. 0.5 microvolts for 12 decibel synod. Good. So I'm glad when I was 19 I spent a lot of money spending £6.99 a time on these service manuals. We've scanned these so that it's easy to run them off like this. This primarily is the early version. It's a bit of a swine to use this service manual with the later version because none of these steps actually figure. So what do they have you do? It's just frequency. They're going to start with the receiver section. We're going to start with the phase lock loop section, because surely if that's not right, then none of that's going to be right. So you've got a lot to this. I've got to make sure absolutely that I am working on the right version. So stroke A is the LC7137. So the one without the suffix A is the PLL02A. If I remember rightly, the instructions refer to the ordinary version, the early version. Just make, I'm sure I'm absolutely correct. It's not the nicest one to work with. You kind of got to find your components with this overshaded look. That certainly, it looks like it's the one with the 3 crystals. Yeah, it's. So we've got to try and test point 3 and adjust T8. You know, trying to find test point 3. Well, we'll probably do it from the bottom side and then work round if we can. I think I've seen 2 others ever in 40 years. I've covered it on this channel before. So, can I find it on here? So we can see test point 2. Test point 5. Test point 3. So it's between T7 and T9. Between T7 and T9. So now we've got to decipher where T7 and T9 is on here. Perhaps I can see the radio easier. No, I can't. Well, T7 and T9 are there. So if we kind of transfer that over, the test point is in fact there, and it is actually a proper test point just there in the set. It doesn't say that it is. It just says TP, it doesn't say TP3. So it's a lot of reading between the lines like that. Right, we'll go back to that page and we'll get ourselves set up. You're going to see that every single thing we do on here is a lot of work. But when they're being screwed up like this, it's absolutely necessary. So we're going to connect a frequency counter. We're going to use the oscilloscope for the sheer convenience of it fitting on the bench and you can see it. First of all, we'll just check that this is negative earth chassis or whether it's a floating chassis. Well, that's a good enough test for me. I've put my probe between the chassis itself and any of the metal bits, so it's a negative earth chassis. So if we connect to test point 3 and a convenient chassis point and switch on the radio, we should have a reading. .51. And it's dancing around. Take the negative to a nearer point. And it's dancing around. It's just, I can't get an accurate enough. Let's twist this lead. So for a start, this hasn't worked out. We'll use the frequency counter on the test equipment. Switch that off for now. So it's 36. Let's put the inset camera on and over to the frequency counter. We haven't actually got the right lead there, just to make matters, so we'll borrow the one off here. I'm going to twist these as much as I can so that for the minimum loss. $38.485. You know, it's just not right, is it? Let's try the other input. So he's dancing all over the place on that one as well. He's pretty stable on there, but it's mildly, it's miles out. Let's see whether we can adjust T8. Well, it's got to find T8 first. It's actually the one which has got its wax intact. Well, in view of the wax being intact, and in view of it being nowhere near where it should be at 36.61, we're going to use the second signal generator afterwards to adjust this. I can't think it's going to be miles and miles out, and from what we heard with the test first on, it wasn't miles and miles off frequency. So we're going to have to skip that part because I just cannot get a sensible reading. So this is our first point and the first stumbling block. So we're going to have to move forward to step 2, which is connect the counter to IC4 pin 3. So IC4 is the phase lock loop, and can we get to pin 3? Well, yes we can. Let's hope there's a bit more oomph behind this one. So that should be 10.24, and it's not that far out, is it? So now we can adjust 10.24. It's VC2 we need to be adjusting. And VC2 is the one up there. When I take my hand away, you'll see. How about that for 10.24? So it's the crystal trimmer just there, VC2. So you've got the 3 crystals, 10.24, whatever the receive is, and then that other one which presumably is transmit. So next we go to test point 1. I think we're on the VCO now. Test point 1, did we spot that? Test point 2. Test point 1 should be round about, shouldn't be too far away from the IC4. It should be round about capacitor 83, resistor 65. And there we have it. So we'll get the multimeter out. One end to chassis. Oh, channel 1. So at channel 1 we should have 2 volts plus or minus 0.3. Well, we're actually spot on, aren't we? However, this is a demonstration, so we want to adjust it. So I need to find T6. T6 is the one right next to the test point. So again, it's the one with the wax in it. It's never been touched. I'm in danger of melting that wire. So as you can see, that is the correct one. .01, 2.02. Just close that back up again. So we've done the VCO. So the next thing they'll have you do is to put an RF vacuum voltmeter on pin 1 of IC5. And adjust T7 for maximum. So what we're going to use, I know what we will use. If we can get it in, we'll use the RF probe. If we can get it in, let's see where IC5 is. So IC5 is this one. I want you to get it on pin 1. And of course you can't get to pin 1, can you, because it's not it's a single in line chip, so everything's on the other side. So we're going to have to put this on its side, take the bottom off. Screwdriver doesn't fit that screw. Plenty of afterthought capacitors on there, aren't there? So pin 1 is that there. So somehow we've got to hold that on there and twiddle T7 at the same time. So which is T7? Looks to be the middle of the top row. I think it's that one. That's 2. Three, 11, 10, 8, 12, 9, 5, 2, 3, 8, 7. Seven is the center one here. So holding that carefully in position whilst probing pin 1, so we'll just try that once again. Oh yeah, that's clearly, look, we've got a clear show. So that's definitely my peak. I wasn't far enough in with the trim tool before. Good. So we've got we've got a positive indication on there, which is great. So it wasn't very far out at all. I hardly moved that to get that peak. But this is going to be the best setup BInatone Route 66 Mark 1 ever. It's going to whistle scratchy corner. So we've done that. So now in TX we're going to put the RF vacuum tube voltmeter and counter onto test point 3. Well, this is novel because we didn't get a rather good reading, did we, using that? So perhaps in TX mode we'll have a better outcome. So we're going to start by adjusting VC1. And VC1 is a trimmer down there. So once again we'll try using this. So remember, this adjustment's failed once. Not this particular adjustment, but using this test point has failed. But this time we're going to be in transmit. It doesn't say what channel we're on. So if in doubt we're on... I don't think it matters, you're not looking at that. I'll go to 20. We'll go to test point 3 once again. And now we're going to transmit. We're just not getting a frequency out of this at all. So I'll go back to the frequency counter, which is still on your screen. Press transmit. Just find this, you know, this is laboratory and expensive equipment, and you know, to not get these readings, it makes me wonder what they were using. Because that and this apparently don't seem to be sensitive enough to do these alignments. I don't get it. Let's go back to this. I can use the spectrum analyzer. I've never tried that for this type of adjustment, but that might be something we've got to do. So it's T9 for maximum indication. T9 is this one. Nope. Let's go back to the frequency counter on your screen. Nothing. So the alternative plan is we'll try for maximum using this. So you can see we're absolutely sure there that we have got maximum. So we've done that, but we can't see the frequency. So we'll have another go at trying to see the frequency. I'll twist this as much as I can. So we don't need to adjust that coil anymore, but we do need to adjust VC1 frequency trimmer. You know, just not getting this 10.695. Well, I'm going to pause the video and see if we can see it on the spectrum analyzer. Okay, well, something different's happened. I still can't find it on 27, on 9 point something megs, but putting it on the spectrum analyzer, I've actually got it showing as 27.791001. So it's actually, of course, our frequency. So instead of us setting it to 9 point something, we'll do what the spectrum analyzer says and set it to 27.79125, because this is our transmit adjustment. Right, we'll just press auto again. And there we are. So we've set it to the real frequency and not the a third of it. I'd say I just do not know what test equipment they were using at BInatone to come up with these figures. So we know we've got 10.24 right, we know we've got the transmit one right, we can derive the receive one using a second signal generator later. So hopefully that's now covered up the really swine crystal mixers. I'll tell you what, we'll do that right now. We'll do that receive one right this second. So we'll put the oscilloscope away, which actually didn't help, even though it should have done. We ended up using the rather sensitive RF voltmeter. So we'll get the second signal generator out, which is that little Chinese thing I use. So on here we're going to get 10.695 come up. Just make sure we're still on frequency, or we weren't on frequency, were we? Because I'll just go over to the frequency counter, because we now need to set the signal generator so it's 27.79125. There we go. So we want this on 10.695. So it's the yellow socket. Why is that altered? Okay, so we've got 10.695. Just move that out of the way a bit. So that's our main signal generator. We'll take the tone off that. We'll introduce this at 10.695. We should just need to wave this in the vicinity. And it's this coil which we couldn't previously adjust because we couldn't get a reading. The little tiny bit of adjustment, I don't know whether you heard that. It was a low groaning, and we just nullified that. It's now 0. So be clear what we've done here. We've got 2779125 on the signal generator going in the normal way. We've got 10.695, which is the IF on here. And does that mean we can adjust it a bit more? Yes, you can hear it better in this position. Spot on. So it was there before. There we are. Switch that off. And we've set the transmit with VC1. We've set the 10.24 with VC2. So don't think you can just do transmit and receive because it's going to come in automatically. It isn't. The critical one is 10.24 on these. And if you get that wrong, the intermediate frequency is going to be out. So even if it transmits on the right frequency, it's going to be lopsided on receive. So that is the correct procedure. It was absolute whatsy take, but it's done. So we're back to square one because the radio is still as insensitive as it was and transmitting as poorly as it was. So we've not done anything except the fundamentals. We've done the groundwork, the spade work. I'll put this lid on so we've got no capacitive effect. Check we're somewhere like on frequency. Slightly high now. So we set the 10.24 with the lid on, and to be honest, I need to recheck the 10 point this with the lid on again. No, that's fine. So I should have had that bottom lid on for that. Right, so we're set up. They want you to start with transmit. They want you to start with receive. My training is to start with transmit, and that's what we're going to do. So we're going to adjust 10, 11, 12, and 13. Let's just find where they are, if we can actually see that layout. So 10 and 11. Ten, 11, well, we'll do that. We'll do those. So we're going for maximum, and we're not showing you the right meter. So at the moment we're at 900 milliwatts. I've inadvertently done a receive one. 10, 11, he's there, still at that kind of level. And 3, 5, and 6. That's 5 and 6. That's 3. But we've still got to find out where 12 and 13 are. They're here. So 10, 11, 12, 13. Into transmit again. Maximum. To be honest, none of those were out. Still there at 1 watt, but it's in a better position. So this is where we're going to need the spectrum analyzer back on. I'll just put this 10 dB attenuator back in. Precautionary, because we're not going to give it a direct input unless we use the spectrum analyzer with one of those toy type walkie-talkies. Put that there. I'll tell you what we'll do. I'm going to switch the radio to low power. The spectrum analyzer can handle 1 watt, and so we're going to put the direct input through the 10 dB attenuator already through a 10 dB attenuator. So we'll do this with the spectrum analyzer. So we're on low power and just go over to that screen. We'll press transmit. There we have transmit. So let's see whether we can get a maximum on the spectrum analyzer using low power. I don't know why it's dancing about. No, not going to proceed with that. I don't know why it's dancing about. So go back to high power. Yeah, there's clearly a dry joint somewhere on this. Let's go back to the normal meter. No, I can't adjust anything because there's a dry joint. Pause the video and have a look for that. Okay, so I've got to the bottom of the transmitter and I'll come to that in a moment. Just need to make sure we've got this filter set right. So we'll go with the spectrum analyzer once again. It's just loosely coupled this time. And we've got that little bit there, which is, let's get the marker on that. Peak, where's my peak button? It's minus 63 dBm. I've got these at peak on the output meter. And that looks absolutely fine to me. So, interesting reason why it's only passing 1 watt. Just look at the current consumption is now 1.3 amps, which is what you'd expect. You've got a preset here that is power. And it's a bit ambiguous on here because it says adjust VR6 and VR7. Well, in fact, it's VR6 is 4 watts and VR7 is 400 milliwatts. So, like, they didn't quite know what they were doing there. So you set that to full, and we weren't getting above 1.2 watts. I then looked at the output transistor, and it's a 2SC2078, that's what I've taken out. It's absolutely fine. It's not faulty in any way. I put a brand new genuine one in at great expense, and the new one is actually lower gain than the old one, very slightly. This is 56, that's 47. We can always tell when these are fakes when they start reading 140 gain, when they're actually rebadged audio transistors, which are probably manufacturers' fallouts. So the problem is this has been changed. This is a second-hand transistor, and what they've done, they've added a bit of wire on to the legs because they're not long enough to go on in this application. You can't do that. You can't extend the legs of these type of devices because RF hovers and it gets to something which is spiky and it's going to say no. So we've replaced that. I won't throw that away because some sets that will fit in and there's nothing wrong with it. You can't extend the legs. So then, as I went through the tune-up, the reason it was going a bit on and off, I've taken both these coils out. I've cleaned the wires with the wire brush, the fiberglass brushes I've got, and they're both dodgy. Put them back, and now we've got proper adjustment, and we'll go back to the RF meter on the test set, and where we've got a full 4 watts. So that's the 3 watt scale, that's the 30 watt scale, and if I turn the power preset up, you'll see it rises to about 4.4. There we go. It's a bit iffy actually. I'll just give it a quick spray. Seeing as Mr. Chippy's service salt here. There we go, 4 watts. Spot on frequency. So now we need to set 400 milliwatts with the other power control. And now I've actually brought up the normal power. That wasn't far out, it was 450 milliwatts. So low power is 400 milliwatts, high power 4 watts. So we're there, and we shouldn't be having any going on and off. It's absolutely solid now. So we've checked that with the spectrum analyzer. I don't know whether you saw me peek it first time. It's spot on. So we've covered check frequency of all channels. What a bizarre thing to do. If it works on one, it works on them all. Not going through all 40. What they haven't said is the power meter. That's swinging across nicely. So I'm not quite sure. Hello, my transistor test is playing for a walk. I'm going to have to look at the circuit diagram now, because I don't want to leave transmit without having done VR4, it says so. VR4. So VR4 is that one up there. And there it says 4 watts beautifully. Now deviation really needs covering. So are they telling you about deviation anywhere? No. Don't tell me they've put it in with receive. No. Okay, well they've forgotten deviation. Just have to find that. I think we're now 2 hours into this setup, you know. So deviation, the whole idea is we're going to have that varactor diode there, and somehow we're going to control the audio into it. So I'm just looking for a preset. Which is likely to be able to control that. Peter? Well, let's go the other way. We'll look at the microphone circuit. So once we've gone through PA, you've got speech processing partly based around the audio IC, using it as a preamp. So there we are, we've got it. It's VR5 is going to be deviation. VR4, VR3, can't read that one. That's going to be the Squelch because it's over by the IF chip. The one I can't read, I bet is it. I think we're doing one of my photos of this set. for future reference. VR4, that is VR2 that we can't read. How bizarre, VR2 shows us the Squelch. VR1, VR2, VR4, VR3, 1, 2, 3, 4. Ah, it's at the back there. Right at the back there. Right, here goes. Get the little oscillator out, the Korg chromatic tuner we use. That was at full, so we've turned it down a fraction. Voila, it's now too low. Voila, it's still too low. How can that be? Voila, it's now spot on. So it was not quite full, but not far off. Good, that's now covered everything on transmit. VR5 hidden away there. So that means we've got 3 presets to mess with on receive, doesn't it? That's interesting. So let's go into receive. So on receive it sounds wrong. I'll tell you that for nothing. So let's have a look at where the detector is, which we'll be starting with. Whatever they tell you to. Looks like T4 and 5 a detector. Let's have a look at that circuit again. I can agree with T4. So I'm expecting that one. That's T4 alright. So just set the volume so we've got a nice trace on there. I mean, this sounds like it's miles out, but let's see. It's not a happy bunny, that one. It's actually too stiff for any of my proper tools to safely turn. So we're going to use a screwdriver, which you should never do. If this breaks, it'll be looking for a scrap chassis. Absolutely miles out, just as I predicted. You've got to put absolutely no pressure on that. because it's been screwdrivered, it's not broken, but it's damaged, and so I've had to use a screwdriver, as you saw there, with the greatest of precision. So that is a massive improvement. Right, we'll go over to the cyanide meter, we'll put that bench light on. So hopefully everything else is straightforward. They say they're harping on about transformer 5. And I want you to look at the S meter on the radio to do that. I find that a bit bizarre. Is that 5? Yes, it is. Well, I've adjusted it from, as they say in the manual. I don't think I've done that before. Wasn't that far out, and then it's T1, 2 and 3. So that must be somewhere like those. Let's have a look at the layout again. That's straightforward enough. It's the 3 in the middle. 1, 2, 1, 2 and 3. I'll make sure I'm absolutely right before messing with it. Am I on the wrong one? I'm looking at the wrong layout. Yeah, 1, 2 and 3. Got the filter there. 3, 2, 1. Yeah, and I can see T3 on the board, so that we're right. So we'll drop that for the usual 4 dB. So that coil was miles out. That was alright. I think this one's been screwdrivered as well. I could get my fossil bronze tool back off Mr. Chippy's bench. There we go. 1, 2 and 3 set. I think that's it. So with VR3, I'll now go over to the attenuator, ready for our next thing. With VR3, we're going to set the S9 position of the needle. It's absolutely spot on. But just to prove we've got the right preset, yeah, that's about the first thing that's been spot on this set. And then Squelch. Now you've got an open and a closed Squelch, so this is unusual. We've got to follow this. Set the Squelch to minimum. They actually want the Squelch to be maximum of 20 microvolts, which to my book is wrong. So what they want is, I'm going to change the figure though. to 100 microvolts. It's alright if there's no residual background noise, but there is, so that's be too weak a squelch to use in the town. So squelch to minimum, which is where we are. Turn fully anti-clockwise VR2. So which one's VR2? Well, that's VR1. So I think that's VR2 because that's 3 and 4. I know we've done this before, but I didn't write it down. You wouldn't expect me to. Just absolutely make sure we're right here. Yeah, that's VR2. So turn fully anti-clockwise. It's a bit dirty. Okay. Turn clockwise until the squelch opens. There we are. We have done. So, with 100 microvolts, with 20 microvolts on the signal generator, turn VR1. So we'll put 20 microvolts on the signal generator, like they say. That's 30, that's 20, so we've now 20 microvolts on the signal generator, just as they say. Turn VR1 fully to clockwise. So VR1 is now fully clockwise. Squelch is now to be to max. And then they say, turn the squelch, turn anti-clockwise until you have squelch. There we go. In actual fact, it's still too strong, so we'll just back that off a fraction. That's 100 microvolts where I want it. So using their instructions plus a little bit of adjustment there for where I want it, we've now got squelch action. So we've done the 100. Let's go and see where the sensitivity is now. We're listening to 0.3 of a microvolt, and I'm going to switch the signal generator to standby. Set the squelch to threshold. Switch the signal generator back on. It's come straight in. Squelch is opening. I'll tell you where. It's quite a wide hysteresis, this. So it's opening at 0.95 of a microvolt. It's not closing until 0.45 of a microvolt. So it's very wide squelch. In fact, I think the squelch is going to work one of the best. So we now need to see what the synad is. So we'll go back up to there. And twiddle my attenuator till we get 12 dB, which is about there. And it's now, it's a shade away from 0.6, about point. We could still say that was 12. It's 0.58 of a microvolt. It's 0.58. So they say it's supposed to be 0.5. Take that with a pinch of salt, and we don't know that they haven't used PD mode. We just don't know. So all we can do is the best we can, and that it's within the kind of parameters that we would expect. So it's 0.58 microvolts for 10 dB synad. That's now doing 4 watts. That's now spot on frequency. That's 2.2 to 2.5. And there we are, and we've set up the squelch. So that is a real, that initial setup is an absolute pain on this version. I'm going to take a photo, I'll take a break, I'll go and do some organ work, and I'll just come back and we'll put it on the air. Onto the aerial, I mean, not an on the air test. I don't think Mr. C's available today, so we'll delay this one. Right, so we'll bring this to a conclusion now, and we'll get the aerial plugged into it, and we'll test it on PA, like we've been doing recently. Seems to be an interesting PA use. Whoops. And put the squelch up a bit, and we'll plug in the PA speaker, which is mounted on the wall. See what happens. Testing 1 2, testing 1 2. Not a lot. Yes, it does. 1 2 3 4 5 5 4 3 2 1. So there we are. Now then, we've got a snag. The receive bulb has failed. So we'll open it back up. Right, we'll go back onto this radio. It now says receive. Let's have a flick round the channels. It's certainly got the sensitivity. As ever, $19 Roger. Nobody near me, so I presume he's 35 miles away in Nottingham. That's probably 35 miles away as well. That's farmers around here.
Okay. No, I do not have a green.
Cool, he's off frequency.
I thought you was a digger driver. I'm sort of a bit like a Ford, so I'm trying to...
$19 Roger. Okay, well there we are. So that'll get Scratchy Corner tested. It won't be today. Mr. C's not available today. But we'll get that done, and tomorrow we'll do the other box out of box 30. The other radio out of box 30, which I've already forgotten what it was. Oh, I think it's a Comtron, and I think it's come with a mic. I wonder if the mic works. That'd be a first, wouldn't it? So thanks for watching the BInatone Route 66 Mark 1, the early version with the PLL02A chip, which is quite a swine to set up, and this video is probably far too long. Thanks for watching.